Okay, the masked professor is on the air once more. Ugh. Oh dear. Um,
Zoom. Enter your meeting ID followed by pound. Enter your participant ID followed by pound. You are in the meeting now. You are the first participant. Please stand by.
There's no pant like a participant, like no pant that we know. All right, now we're finally got everything lined up, and we're ready to do Chapter 11, Storage Systems. First of all, are there any questions? Of course they're not, I'm the only one here. All right, so storage systems in the computer-aided manufacturing paradigm come in two stripes. But first, storage system function to store materials. For example, parts, work in process, finished goods for a period of time and permit retrieval when required. Used in factories, warehouses, distribution centers, wholesale dealerships, and retail stores. It's an important supply chain component, and there are automation methods available that could improve efficiency. So when we talk about storage system performance, the performance measures we use for storage systems are, first of all, storage capacity. That can be by two measures: total volumetric space, or the total number of storage compartments, or unit loads. Our storage density is the volumetric space available for storage relative to the total volumetric space in our facility. Another measure is accessibility. What is the capability to access any item in storage? System throughput, the hourly rate of storage and retrieval transactions, and utilization and availability. The utilization is, of course, how much we're using our storage system. Availability is the reliability of the system. All right, so we have conventional storage methods such as bulk storage, that's storage in an open floor area. There, our problem is going to be getting the proper balance between our storage density and accessibility of goods. Rack systems, that is expressed as structures of racks for pallet loads. This permits vertical stacking of materials, in fact, pretty high stacking a lot of times. Shelving and bins, these are horizontal platforms in a structural frame. Steel shelving comes in standard sizes, but finding items can be a problem. And drawer storage, the contents of every drawer can be viewed if we open the drawer. Here we have bulk storage arrangements. A over here is a high density bulk storage, but again, it provides very low accessibility. Our B is bulk storage, but we have it formed into blocks for easier accessibility. This is a typical rack system for pallets, and we can stack very high, depending of course on the weight of our loads, and we can get items in and out fairly easily with forklifts. When we have drawers, we have some kind of cabinet arrangement that has drawers in it, and then inside the drawers we can have dividers and partitions. I think we're all pretty familiar with this. The difficulty with this type of storage is always keeping things straight and keeping them well labeled. And of course we have automated storage systems. These are mechanized and automated storage equipment to reduce the human resources required to operate a storage facility. They represent a significant investment to put them together. And the level of automation varies. If it's a mechanized system, we have an operator participating in every storage and retrieval transaction. In highly automated systems, the loads are entered and retrieved under computer control. Yes, is somebody trying to send me a Morse code signal? Okay, I guess not. All right, so what are some of the objectives we might have or reasons for automating storage operations? One is we can increase our storage capacity. We can store items more densely in an automated system than we can in a human operated or mechanized system. That also increases the storage density. We can use that to get back some of the floor space that is being used for WIP. We can improve security and reduce pilferage this way. We can reduce our labor costs and or increase productivity, improve safety, improve our inventory control, improve our stock rotation, improve our customer service, and increase throughput. Now, not all of these will be true every time, but they are considerations when we start talking about automating our storage system. So the types of automated storage system, the first is the fixed aisle automated storage and retrieval system, often called AZORs. This is an ordinary kind of rack system with a mechanized or automated storage and retrieval machine that stores and retrieves the loads. It has linear motions in the storage and retrieval machine. The other type is the Carousel Storage system. This is an oval conveyor that has storage baskets or shelves, some other mechanism to contain individual items. The revolution of the conveyor trolleys around an oval track delivers baskets to a load and unload station. All right, so here is an AZORs system. This illustrates one aisle of a fixed aisle automated storage and retrieval system. All right, so there's a machine here, the storage and retrieval machine, that goes up and down the aisle and can store in any of these storage modules. All right, we define this by the length of it and the height. So our AZORs types are unit load AZORs. This is going to be a large automated system for pallet loads. A mini load AZORs, which handles smaller loads in bins or drawers so that we can do order picking type of work. A man on board Azores, where we have a human operator who's riding on the carriage to pick items out of storage. An automated item retrieval system that can pick individual items out of our storage. And vertical lift modules. There we have a vertical aisle rather than a horizontal aisle like we do in other Azores types. All right, so with our Azores applications, if we're doing unit load storage and retrieval, usually we're talking warehousing and distribution operations. So the Azores types would be unit load or deep lane that is used by the food industry. Now when I worked at the Corpus Christi Army Depot, they had an entire Azores building. It was huge. You could have put maybe 2 basketball courts in there. But with these kind of Azores systems, we must keep integrity of the information about where things are stored and what they are. One of the favorite tricks at the Army Depot was to store something under an innocuous name that you would particularly want later so that nobody else knew where it was. When we're talking about Azores in order picking, then we're talking a mini load, man on board, item retrieval type of system. And for a work in process storage, we can use those to help manage the amount of WIP in our operations. Sometimes we need buffer storage between operations that have different production rates. If, for example, most of the factory spends 10% of its time building product A, but there's one part of product A where we have to have people dedicated 100% of the time, obviously we're going to have a place to store all that WIP in between operations. Okay, so this can support a just-in-time manufacturing strategy. When we talk about carousel storage systems, there can be horizontal type and vertical types. The horizontal type is similar to the way the storage works at a dry cleaner's, except that it goes only in an oval loop rather than kind of a snake line idea that I've seen in some dry cleaning facilities. So items are stored in bins suspended from the conveyor, and it could be anything from a pretty small carousel to a huge 30-meter long carousel. Horizontal is the most common type. A vertical carousel storage system works much the same way, except it operates with the loop being vertical. It uses less floor space, but you have to have a lot of overhead room to use it. I've seen both of these types used often poorly because the sense of order is lost. So there has to be a lot of discipline with any of these types of storage to make sure that we are storing things in their correct space so that they're not lost or misused. So this shows a horizontal carousel storage system. You can see there are a lot of different carriers. Each one has different bins for inventory. It travels around this oval track so that we can call it up. We know that, for example, something is stored in section A10. Okay, well, we call up conveyor A, we look in section 10 or shelf 10, whatever, and we get our part. For carousels, our applications, we can use them for storage and retrieval, whether that's order picking or kitting parts for assembly. We can use them for transport and accumulation. We can, the one that we see here is open. Right, so in other words, there could be assembly stations along the side here. Ordinarily, what we would do if we only had one load-unload station is we would actually have the rest of the carousel covered so, to avoid any safety issues. We can store our work in process. They say that this is common in the electronics industry. There you have me. I've never worked in the electronics industry. And unique applications. Well, by definition, a unique application is something that only happens once.
Professor Webbing,
Yes, ma'am.
is there a way to maybe turn off one set of lights? Because when I went through and rewatched the videos, it was kind of hard to see the PowerPoint.
That's certainly a possibility.
I'm sorry to ask.
No, it's okay. I have been meaning to do that. I just forgot.
Thank you.
So happy to help. As I said, by definition, if it's unique, there's only one of it. What they really mean is not a unique application, they mean unusual or rare applications. All right, so when we do analysis of our automated storage systems, a fixed aisle automated storage and retrieval system. Well, first of all, there's sizing it. Sizing the Azores system is important. We don't want one that turns out to be way too small for what we want. By the same token, we don't want one, because they're so expensive, that is way too big for what we want. We want one that is just right. With carousel storage systems, again, we want to know what is the storage capacity, and we want to do throughput analysis, whether we're talking a carousel or a fixed dial Azores system. All right, so here we see a fixed dial Azores system. We see the top view and we see the side view. Each of these little cells represents a storage compartment. Here in the side view, we see this one. We have 9 storage compartments long and 6 high. And we would calculate by what their size is exactly how big this would be. In other words, our length and our height and our width. So we think about what would the travel on an Azores system look like? If it's a single command cycle, in other words, we give it something, it goes to the location and puts it away, and then returns back to the origin, then that would be something looking very much like this. And we would calculate how many trips a day it would make by assuming that the average trip is to the center of the Azores machine. If it's a dual command cycle, in other words, we can send it with something, it stores it, then it goes and it gets something else and brings it back, then that's a dual command cycle, and we would calculate that as travel to half the length, half the height, and then travel to 3/4 height, 3/4 of the length, and back. And for a carousel storage system, in that case, it's going to be the width and the length, and of course the speed with which it runs is going to be a huge consideration. Okay, so that makes it clear as mud, right? All right, so this is kind of a short chapter presentation. So my plan is, stop the share. my plan is that we will run through some problems. First of all, I'll point out that starting on 333, we have examples and our formulas. All right, so let's look at problem 11.2. And we are given that our pallet loads are equal to 1,000.
You said
This is on 339.
11.2, right? Okay.
Right. That X is equal to 1,000 millimeters. Y equals 1,200 millimeters. And maximum height of a unit load is 1,300 millimeters. All right, so our automatic storage and retrieval is going to have 2 aisles.
Pre-rec structure, approximately 5 times its size.
Our length is equal
2 miles.
to 5 times height.
Rack structure.
Our rack is equal to 500 millimeters above the floor. Oh, and our allowances are A equals
150 millimeters.
150, right? B
It's 200.
equals
200.
200.
And C is 250.
All right, so they're making it a little bit tricky in that we have to calculate backwards to an extent. Right, going back. our width equals 3 times x plus a.
Okay.
Our
Length.
length equals ny. So New York times y plus b. And our height equals nz times z plus c. All right, so I've got to quickly look.
Oh, sorry.
Boy, he's trying to scare us to death here. All right. We know, and we also have, did you see the message I left you on your desk, a phone message?
Oh, okay, okay, I will.
Well, damn it, man, go look for that.
Yeah, I'm so excited for this, honey.
As well you should be.
This one.
I don't know what he was holding up there. All right, we know our capacity is 2 times
Free gel card?
ny times nz. Oh, should be lowercase in here.
Oh, capacity pipe.
All right, so really, there's an extent to which it turns into an algebra problem. All right, she doesn't want to believe me when I say that. Right, because we know we want 1,000 pallet loads and we have 2 aisles, right? So that means that one aisle is going to have how many pallet loads? If 2 aisles have 1,000, how many does one aisle have?
You said 1,000?
I believe that's the number that they give.
Pallet load is 1,000.
Right, so if 2 aisles have 1,000, one aisle has
1,000. You said it's 2 aisles and they both have 1,000. Your pallet load's 1,000. Each aisle would have 1,000.
Okay, it's 1,000 pallet loads total. It's going to be on 2 aisles. How many does one aisle have? Assuming that both aisles are equal. What's 1,000 divided by 2?
You're 500.
There you go.
Oh, I was thinking each. Each had it. Sorry.
No worries.
I was like, 2,000?
All right, but each aisle has, two sides, right? So each side has 250. Which I don't know if that's going to help us. since we know that length is equal to 5 times the height, we can say that ny times the quantity y plus b equals 5 times in z times, oh, excuse me, that should have been, oh, right, nz times z plus c. And we know our capacity equals 2 times ny times nz. Oh, bloody hell. A lot of reverse, all right. So next we're going to substitute all the numbers that we've got and try and knock some of this down. So that means that n y, y is 1200 and b is B is 200. Right, at the same time we know that Z is 1300 and C is 250. All right, so since we know capacity equals 2 ny times nz, and we know that that is equal to 500. All right, so we can say that we can transform that and say nz equals 500 divided by 2 times n y. Right? Algebraically, that makes sense? You don't seem that confident in my calculation there. But damn it, I'm pushing ahead anyway. All right, so that means over here are ny times 1400, 1200 and 200 equals 5 nz's, which is 500 divided by 2, N Y times 1550.
Equals to the 5 divided, multiplied by that 500
All right, well, I'm gonna go ahead and divide both sides by 5. So that means that this is 80 NY equals, this 5 drops out because we divided both sides by 5. 500 divided by 2 is 250 divided by NY. And then that is times 1550. All right. Now let's multiply both sides by NY, right? So that is 80 NY squared equals 250 times 1550. All right, now we're getting somewhere. Divide both sides by 80. Gives us NY squared equals 250 times 1550 divided by 80. And I'm going off over here, equals 250 times 1550 divided by 80. All right. So that means that NY squared is 4843.75. So NY, even the weariest river winds somewhere safe to the sea. NY then becomes equal to the square root of 4843.75. $69.5971, or probably we should go ahead and call it 70.
So we're calling it 70? 69.59.
Well, I think we need to call it 70 because otherwise we get an NY and an NZ that are gonna be very, very hard to work with.
70 it is.
And since they're supposed to be like integers, all right. Now, that means that now we can say capacity is 2NY times NZ so we could say NZ equals, well, we know that capacity is 500. So equals 500. We divide that by 2 times NY. Oh, okay, yes, I want to accept the correction already. Oh, wait a minute, that doesn't look like it works out right. It's 140. Oh, no, divided by 140, that's where I made my error. So NZ, I'm gonna call it 4.
Call it 4. Okay.
Okay, well, it's been an uphill battle to get here. Okay, but now we can work through this in kind of the ordinary way to find the so our length is equal to NY, which we know is 70, times our Y plus B all right, and that is, of course, in millimeters. Our height is going to be equal to our NZ, which is 4, times 1300 plus C, but in this case, we also have to add the 500 millimeters above the floor. All right, so about 84 meters long and about 6.7 meters high. we can work out and working out the width is super easy because width is equal to 3 times our x plus a Boy, that does not seem like much, but okay. Oh, wait. That was a mistake there. So it's now 98 meters long.
Oh, okay. Hold on. Go back to that. Your length. Okay.
So I hadn't put the parentheses around around y plus b. And that's why it made a mistake. It was only multiplying 70 times y, not y plus b. All right, and on the next one, all right, and that one I calculated correctly.
Okay.
And for some reason, it didn't keep 11.2 as a problem here. All right, so we've got the length, width, and height here. I actually assigned some problems. I assigned the first problem in each of these sections the first problem in each section, because those are the ones with the answers. All right, so I'm expecting that you'll work through them and be showing me your work.
If we, on the work, can we do it through Excel?
Can we get through itself?
No, can we use Excel to do the work, or do you want us to write it over?
No, use Excel. Oh my God. How much longer would it have taken me to do that problem
Oh,
without Excel? No, for God's sake, I want you to know how to go into the world knowing how to use Excel to to do these problems. It's pointless to make you do them by hand. All right.
Solve problem 1115.5, accept.
All right, so 11.6, the length of the storage aisle in a Azores is 210 feet. Boy, I ought to start. And height in feet equals 45.
Horizontal, vertical.
The velocity in the horizontal direction in feet per minute is,
350?
I'm sorry?
So that's 350. Horizontal, vertical speeds, 350.
And also in feet per minute equals 55 feet per minute.
Requires 8 seconds to accomplish. Take
Alright.
deposit.
So time equals 18 seconds. Okay, so all right, so find the single command and dual command cycle times per aisle. All right, so the time for the single command is equal to twice the maximum of 0.5 times the length divided by the speed in the y direction. I'm just going to fix my notation here. Or the 0.5 times the height divided by VZ plus 2 times PD, which is pickup and deposit, all right. Ugh,
Two,
pickup and deposit.
and that one is TTD.
All right, which means that our is equal to twice the max of 0.5 times length divided by our vertical travel, or 0.5 times height. Oh, wait, I'm backwards, aren't I? Divided by plus 2 times. All right, so here I have right, because C3 is the length, right, all right, and the, oh, okay, all right. Here, I get it, all right, I'll fix it already.
Oh,
Oh, what a grouchy, computer.
did that fix it? Okay.
All right, except because our time of pickup is in seconds and our speeds are in minutes, I'm going to have to divide the time of pickup by 60. Wow. Does that make any sense to you?
None whatsoever.
Excellent.
Let's see, G3.
Shouldn't have made that big a difference.
Divided by,
All right, so look, it's either the maximum of the time it takes to travel the length, or the maximum of the time to travel the height. Whichever one of those is bigger is the one that is going to be chosen, right? Okay, you gave kind of a little nod, but I think you were doing it more because you wanted to humor me than because you agreed. So, it looks to me like it's, oh, I know what happened. Because this number is so large, when I put it in instead of the travel in the Y direction, right? Because travel in the length is in the Z direction. Travel in the Y is in the height direction. Right? And you'll notice that our velocity in the Y direction is pretty tepid compared to the travel speed in the Z direction. All right. Let's press ahead. All right. Now, travel for dual command is going to be 2 times max of either 0.75 of the length oh, excuse me, apparently I'm wrong again. It gives me a lot of practice though. This should actually be Vy. The length is the Y direction in these guys' scheme. And Vz for height. All right, sorry, here. I can fix this in a trice. All right, 4.41. All right, I'm liking that number better. Although my student is ready to kill me. Saying, damn it, man. Be cool with all this changing around of your numbers. Height divided by Z plus 4 times TPD. All right, so the time for dual command is going to be equal to 2 times the max of 0.75 times length divided by my Vy, or 0.75 times the height divided by Vz plus 4 times the pickup time, but again, that has to be divided by 60. All right, that actually is I want to say not the entire okay, really what we're ending up doing is working through you're going to be able to steal a whole bunch of this for the homework. All right, we've got a 2-to-1 ratio on single command and dual command. And all right, so if we look and we see RCS times T CS plus RCD times T CD equals 60 times U. Right? That's 11.4 on 335. We can then say, we've got utilization at 85%. We've got the time for CD, we've got the time for CS, and for 11.6, single, we assume that single command to dual command is 2.1. All right, well, that means that two RCD times our TCS plus RCD times TCD equals 60 times 0.85. Okay, well, since we have the time for single command and dual command, that would mean that it's 3 RCD times our, oh, damn it, I forgot. Let's call it 4.42 plus 2.43. That still don't seem right. Equals 60 times 0.85. So RCD equals our 51 divided by these added together times 3. All right, so I need one more. Okay, mathematically somewhere I've gone horribly wrong. However, luckily for me, the metaphorical bell is ringing. Let me just save this, even with there is, this file is being saved on the Computer Aided Manufacturing, and the PDF of Chapter 11 has been saved on there. So if either of those is of use to you, you know where they are. Okay, well, it's been an exciting time. And I will see you on Wednesday.